To start the configuration for TuneWizard, there are a couple of prerequisites. The first one is the DCOM configuration between the client and the OPC server. There is a link on your screen right now to where you can access the procedure for DCOM configuration. The second item is to make sure you start OPC enum services. Once OPC enum is up and running, we can start using TuneWizard. TuneWizard allows the user to use different methods to obtain data for a control loop. For the purposes of this exercise, I will be connecting to a Honeywell TDC 3000 system using an OPC DA connection. To make the OPC DA connection, under Data Source, I click on OPC. I type in the name of my control loop. I can choose the type of controller. We have a Honeywell TDC 3000 system. I could have chosen this particular equation B. If I'm not sure about the type of control algorithm, I can choose from a list of generic PID algorithms. For example, I can choose Series Interactive Generic. And then I'm ready to specify some additional information about the control loop under channels. For instance, I have to define the computer name and the OPC server name. I can type this information in, or I can use the OPC browser. Using the OPC browser, you can point to the right direction in your control network. I can copy now this information to the channels page. And here is the computer name and the OPC server name. I can define what information I need to gather about this particular control loop. For instance, I can define the output, the PV, the set point. The range of these variables goes between 0 and 100. If this is not the case for your application, you can change the range in this section. I can define the parameter that brings in the mode of the controller, and also the tuning constants. Clicking on this button, I can bring data in and make the connection through the connection that I made. So I can see that I have 0.5 for the proportional gain, 0.34 for the integral time, and 0 for the derivative time. Now that I have defined the OPC connection for this control loop, I can perform a number of process tests to gather data which will enable me to quantify instrumentation issues like valve hysteresis and stiction, or estimate the process nonlinearity and variability. In addition, I can use process data to tune the control loop. At any point in time, I can save the work in a TuneWizard file. Now that I saved my work, I can close the application. However, next time I restart the application, I can navigate to the saved file and continue working from where I left off. As I mentioned earlier, TuneWizard allows the user to import data using different methods. Now I will demonstrate how to gather data through a CSV file import. Since this is a new control loop, I will start a new project file. Under Loop Details, I specify the CSV text file import option. I can choose the type of the controller, enter the description of the control loop, and acquire data by browsing the files. Here is my CSV file. By opening the file, I can see all process data for this control loop. I have the timestamp, the process variable, set point, and output of the control loop. By clicking on this Create Data file, I import the data into the View and Select menu. Once I have the data, I can perform any type of calculations I wish.